1. So in our example number 1, we are going to factorize p cube plus p square plus p plus 1, p cube plus p square plus p plus 1. So to factorize the polynomial which is p cube plus p square plus p plus 1 by means of the method called grouping of terms. So first of all, we have to group the terms in such a manner that there exists one common factor or common term in the each and every group. Then now the solution starts. So here p cube plus p square plus p plus 1 is the given polynomial. So in this polynomial there exists 4 terms. The first term is of p cube and the second term is of p square with positive sign, third term p plus positive with positive, and the fourth term that is constant as 1 with positive sign. Then later that implies, so here I am going to group first 2 terms, that is p cube and p square as the first group, because in the first group the elements are the terms are of p cube and p square. So p is common and p square is common in both the terms. Similarly here constant is common, so here 1 is common in both the terms. So now that implies p cube plus p square plus p plus 1 is the given, but by grouping the terms, so I am going to group first 2 terms as first group and the next 2 terms, that is the third term and the fourth term, as one group, as the second group. So that implies among the first 2 terms of the first group, so I am going to take p square as common, because the least among p cube and p square is the p square, so I can take p square as the common in the first 2 terms of the first group. When p square is taken out, so here one more p will be left over, because the exponent of the first term is of 3. So there are already of 2 p's, that is exponent is 2, we need one more p, that is p to the power of 1 in order to add up. So here 2 plus 1 will be of 3. So in this manner I say p cube into p power 1, that is p to the power of p raised to the power of 1, add up the exponents, 2 plus 1 will be of 3, plus p square is already taken out as common, its coefficient will be of 1, so here 1 is left over within the bracket, plus, whereas in the second group is consisting the terms p plus 1, so here p's coefficient is of 1, then now 1 can be written as 1 into 1, so overall I want to take as a 1 as common, because 1 is present in both the terms, so 1 is taken out as common, then only p is left over within the brackets, plus 1 is already taken out as common, so we know 1 once is of 1 again, 1 into 1 is of 1. Then now that implies, whereas in these 2 terms, that is p square into p plus 1 plus 1 into p plus 1, now the common factor is of p plus 1 once again. When p plus 1 is taken out as common now, then only p square is left over within the brackets, plus p plus 1 is taken out as common in the second term. So here when p plus 1 is taken out as common, 1 is left over within the bracket. So it can be written as p plus 1 into p square plus 1. These are the 2 factors of the given expression, that is p cube plus p square plus p plus 1. So in this manner, hence the given expression is of p cube plus p square plus p plus 1 can be written as the product of the 2 factors, such as one is of p plus 1, the other is of p square plus 1. So here factorization, since factorization is the reverse process of the multiplication, when we multiply the factors which we got, that is p plus 1 and as well as p square plus 1, so you will get again the given expression, that is p into p square as p cube, p into 1 as 1p, and here 1 into p square as p square, 1 1 is 1. So we will be getting the same expression which is given by multiplying the factors which we got. So here hence or therefore p plus 1 and p square plus 1 are the factors of the given polynomial which is p cube plus p square plus p plus 1. Similarly, let us go for one more example, that is example number 2. So in our example number 2, we are going to factorize. We are going to factorize 2x square plus 7xy, 2x square plus 7xy square minus 8xy minus 28y square. So we have to factorize the polynomial which is 2x square plus 7xy square minus 8xy minus 28y square. So here the solution starts. Now the given polynomial is of 2x square plus 7xy square minus 8xy minus 28y square. As per the first step of the method called the grouping of terms. So first of all we have to group the terms in such a manner that there exists one common term. So here when we group 2x square and as well as 8xy, there exists x is common and 2 4 8 is common. So here we can take 2 as common, because 2 as common, here we can write 8 as 2 into 4 as the factors. We can take 2 as common and 1x as common in these two terms, and similarly among 7xy square and as well as 28y square, 7, here we can write 28 as 7 into 4, that is we can take 7 as common and y square is present in this term, that is the second term and as well as the fourth term. So here we can take y square also common as in the second and fourth terms. So first of all, as per grouping of terms method, so we are going to group 2x square and 8xy as the first group. So here that implies 2x square minus 8xy. Then now second term and the fourth term as one group, that is plus 7xy minus 28y square. So in this manner I have grouped first and the third terms as the first group and the second and the fourth term as the second group. So among the first two terms I want to take 2 as common and as well as 1x is present in the second term of the first group, and here two terms 2x's are present. I can take 1x as, because x is the least. So here 2 is the least, here we can write as 2 into 4, I can take 2 as common and 1x as common. When 2 is taken out and 1x is taken out from 2x square, so here just only x is left over in the first term of the first group. So here to verify, 2x into x is nothing but 2x square minus 2 number of times is of 4, 2 4s is of 8, x is already taken out as common, just y is left over within the bracket. Whereas in the second group, that is 7xy minus 28y square, so here 7 is the first term of the first, 7 is the coefficient of the first term of the second group, and we can write 28 as 7 4s are. So I am going to take a plus sign in front of the bracket, then 7 as common, then now here it is of y square, 7xy square. So we can take y square as common, then y square is taken out. When 7 is taken out as common in the first term and as well as y square is taken out as common in the first term, just x is left over. Whereas here, as per the problem, it is of 7xy so here 2x square plus 7xy minus 8xy minus 28y square, then the next term will be of, so here instead 7xy square we can write it as per the problem it is of 7xy. So here just x, only y will be taken out as common. So 7 and y are taken out as common, only x is left over. Then now minus 7 number of times is of 4, 7 4s is of 28. Then now out of, say here y square can be written as y into y. Out of 2 y's, 1 y is taken out as common, 1 more y is left over. Then, so whereas in these two terms, say here x minus 4y and here x minus 4y is common in both the terms. When x minus 4y is taken out as common in the next logical step, when x minus 4y is taken out as common, just 2x is left over within the bracket plus, whereas in the second term x minus 4y is taken out as common, so here just 7y is left over. So in this manner, so we got, so that implies x minus 4y is the first factor and 2x plus 7y is the next factor. So here hence, so these two are the factors of the given expression, which is 2x square plus 7xy minus 8xy minus 28y square is equals to x minus 4y into 2x plus 7y. So here these are the two factors which we got. When we multiply these two factors, we will be getting the given expression as 2x square plus 7xy minus 8xy minus 28y square. So therefore, hence x minus 4y and 2x plus 7y are the two factors of the given expression. So x minus 4y and 2x plus 7y are the two factors of given expression, that is 2x square plus 7xy minus 8xy minus 28y square. So here as per the problem it is of only 7xy. So in this manner, by utilizing the grouping of terms method, so here we got x minus 4y and 2x plus 7y as the factors of 2x square plus 7xy minus 8xy minus 28y square.